Hello everyone and welcome. In this video we're checking out variant 1 of October-November 2023. Paper 3, let's get started. Question 1 says, find the exact coordinates of the points on the curve, and it's given to you that this is the curve, and okay, at which the gradient of the tangent is equal to 8. So that means dy on dx equals to 8. To find the derivative of this function, you have to understand this is like a function divided by another, so we're going to have to use the quotient rule here. So when you use the quotient rule, it literally says, okay, the numerator times the denominator, but then you're going to have to get the derivative of the numerator minus the derivative of the denominator times the numerator divided by the denominator squared. Okay, so you have to follow that order and you have to make sure to put that minus sign. So it's really going to be 2x into 1 minus 3x minus the derivative of the denominator is minus 3 times x squared divided by 1 minus 3x, the whole thing squared. And so you get 8 equals to 2x. If you expand this, you get 2x minus 6x squared plus 3x squared divided by, if you could also expand the bottom, you get 1 minus 6x plus 9x squared, right here, 8x, 9x squared. Okay, if you just send this to the other side, you get 1 minus 6x, 9x squared, 2x minus 6x squared plus 3x squared. This becomes 2x minus 3x squared, which must equal to 8 minus 48x, 72x squared. Now if you send everything to one side, you get 72 plus 3, which is going to be 75x squared minus 50x plus 8. If we solve this quadratic equation using your calculator, you get x equals to 2 over 5 and x equals to 4 over 15. Now you're going to find the values of y because they said to find the exact coordinates. So what's it called? You're going to want to find the value of y. Y is going to be, using the calculator here, at x equals to 2 over 5. Y is going to equal to 2 over 5 squared divided by 1 minus 3 times 2 over 5, which is going to be just like saying negative 4 over 5. So we've got the first one to be equal to, so let me, what's it called? Let me just rewrite this as one coordinate. You get 2 over 5 and then minus 4 out of 5. And then what's it called? The same thing for when x equals to 4 out of 15. 1 minus 3 times 4 out of 15. And we're going to get 4 out of 15 and 16 out of 45. So now, okay. And that's it. On an Argand diagram, shade the region whose points represent the complex numbers z, satisfying inequalities. And here we've got complex numbers, but make sure obviously to identify that they're actually 2i, and this is going to be 2 plus I, negative 2 plus I. And then what's it called? Here we also have negative 1, and the argument at z equals negative 1 is going to be between 0 to 1 over 4 pi. So let's go ahead and sketch it. So I'm going to just draw the... Okay, this is weird. Let me fix it. So the imaginary axis and the real axis, and then what's it called? Just write real, imaginary, and then what's it called? Go ahead and label. So here we've got 2i, 1, 2. That's the first point. And then we also have at 2 minus i. 2 minus i, we're going to have, what's it called? Minus 2 plus I, excuse me. So 1, 2. Obviously, it's not accurate, but, you know, we're trying. So this is going to be... Okay, this is going to be the second point. And now we're going to have to, you know, sketch a line right here. Okay. So basically, we're looking for the point of intersection between two circles drawn with these centers. And so you could just get this and draw an arc at a point that's more than half the distance away from here. And then again, do the same thing for here. And you're going to find the point of intersection, which allows you to draw a perpendicular bisector right here. Now, the perpendicular bisector, you can obviously expand it, extend it, and everything. But then you're going to have to draw at z equals minus 1, right over here, an angle of 1 over 4 pi. So an angle of 1 over 4 pi. So you're going to get your protractor and draw a line at 45 degrees. Now here, if I just extend this stuff and extend this stuff, Now for it to be closer, the point has to be, closer to 2i. And so in general, it has to be closer to, this part. And so if it has to be closer to this part, and it also has to be, below here, so it's like everything from here until like the end, okay? And yeah, it has to start from here, I guess. Now let's move on to question number 3. So let me first check if there's no part I. No, okay. Question number 3 says the variables x and y are related by the equation y equals ab to the power of x, where a and b are constants. The diagram shows the results of plotting ln y against x. So it's ln y against x. He says for two pairs of values x and y, the coordinates of these points are 1 and 3.7, 2.2 and 6.46. Okay, so he's given you the points. Again, this is supposed to be ln y, and this is going to be just x. He says use information to find the values of a and b. Well, because we can just draw a straight line here, I might as well just use the concept. So I can just go ahead and put ln on either side. And then you're going to get ln y equals to ln of a plus ln of b to the power of x, which can then be written as x ln b plus ln a, which we obviously can compare to, an equation of a straight line where like c is supposed to be ln a, m is supposed to be ln b, and y is going to be now ln y. So now instead we could just use these values to find the values of a and b. Use these points, I mean. Okay, so now we can use 3.7 instead of ln y, and that's equal to 1 times ln of b plus ln a, and then we have another equation where we're going to be using 6.46 for ln y, and that must equal to 2.2 ln b plus ln a. If I subtract equation 1 from equation 2, you're going to get 3.7 minus 6.46 equals to ln b minus 2.2 ln b, and ln a is going to cancel because it's ln a minus ln a. Now if you use your calculator to find, this is minus 1.2 ln b, it must equal to 3.7 minus 6.46, which is equal to negative 2.76. If you divide by negative 1.2, you will get 2.3 equals to ln b, but he doesn't want ln b, he wants b, so b will equal to e to the power of 2.3. And he said he wants to find the values, not the exact values, so we can just multiply this. We're going to get e to the power of 2.3 equals to 9.974, which rounds to 9.97. That's the value of b. Now in regards to the value of a, we can use any one of these equations where we don't know the value of b, so we can use now instead of ln b 2.3. So 2.3 equals to 3.7. And then solving this, you get ln a equals to 3.7 minus 2.3, which is 1.4, and a will equal to e to the power of 1.4, which is the same as 4.055, which rounds to 4.06. Okay. Question number 4 says the complex number u is defined by the following, where a is a real number. He says express u in Cartesian form x plus iy, where a, x, and y are in terms of a. So in order for us to express it this way, we want to get rid of the denominator. To get rid of the denominator, an easy trick to do this is actually to multiply by the conjugate, the complex conjugate. So I'll multiply by the conjugate up and down in order for me to remove the denominator, or remove the letter I from the denominator. So you get 3a plus 15i, and then plus 2ai, and then 2 plus 2 times 5 is going to be negative 10, because I squared equals to minus 1. Divide this by a squared plus 25. Now if we fix this up, so we're going to get 3a minus 10 plus 15i plus 2ai. Now if we divide separately, that would be great. So this is how I express it. Now I can take I here as a common factor outside, and I'll get 15 plus 2a divided by a squared plus 25 into 3a minus 10 divided by a squared plus 25, where this over here is x and this over here is y. Then we have, given that the argument of u equals to 1 over 4 pi, find the value of a. So if the argument of u equals to 1 over 4 pi, that means that tangent of a complex part divided by what's it called, the real part equals to 1 over 4 pi. Because in order for us to find the angle, what we do is we just get the complex number, and then we get the imaginary part divided by the real part, and that's going to give me, and then we're going to get tangent of this angle, then we can get obviously tangent inverse to find the angle. So when the angle is equal to 1 over 4 pi, we know tangent is going to equal to 1. And so that means that the complex part over the real part will equal to 1, which means that the complex part equals to the real part. In other words, 3a minus 10 over a squared plus 25 equals to 15 plus 2a divided by a squared plus 25. Now a squared plus 25 cancels on either side, and you're going to get 3a minus 10 being equal to 15 plus 2a, a being equal to 25. There you go. Okay. Question number 5 says, given that sine of the following minus sine of this equals to cosine, and we've got lots of compound angles. It says find the value of tangent x. Okay, so first let's just simplify, because obviously here we have x, not x plus 1 over 6 pi. So let's remove the compound angle. You're going to get sine x cosine 1 over 6 pi plus sine of 1 over 6 pi and then cosine x. Okay, so simplifying this first is this is basically equal to sine of x plus 1 over 6 pi. So it can be written also as cosine of 1 over 6 pi actually happens to be root 3 over 2. Okay, so we're going to get root 3 over 2 sine x plus 1/2 cosine x. Okay, and that's going to be, as we've mentioned, sine x plus 1 over 6 pi. Let's find sine x minus 1 over 6 pi. It's going to be quite literally the same, just with a negative sign. So it's going to be root 3 over 2 sine x minus 1/2 cosine x. Now when it comes to okay, now the left-hand side is going to be, in general, the first one minus the second one. And so it's root 3 over 2 sine x plus 1/2 cosine x, which must be subtracted from root 3 over 2 sine x plus 1/2 cosine x, and so the left-hand side is equal to just cosine x, because sine cancels and 1/2 plus 1/2 equals 1. Now in regards to the right-hand side, we want to get first cosine x plus 1 over 3 pi. Cosine of x plus 1 over 3 pi is going to have an identity of cosine x cosine 1 over 3 pi minus sine x sine 1 over 3 pi. And this is actually equal to, 1/2 cosine x minus root 3 over 2 sine x. Now in regards to the opposite thing, it's going to be just reversing the sign. So it's 1/2 cosine x plus root 3 over 2 sine x. Now if you subtract the first two, cosine of x plus 1 over 3 pi from cosine x minus 1 over 3 pi, you're going to get, that's the right hand side, 1/2 cosine x minus root 3 over 2, and then minus the second one, minus 1/2 cosine, and then minus root 3 over 2, and so you get cosine to cancel, and you're going to get root 3, negative root 3, right? So negative root 3 sine x, that's the right hand side. Now if the left hand side equals to the right hand side, so cosine x equals to negative root 3 sine x, and if you want to find the value of tangent, then you'd want to divide everything by cosine to get to tan, because sine over cosine equals tan. So negative root 3 tangent x equals to 1, which means tangent x equals to negative 1 over root 3, which can also be written as negative root 3 over 3. And this is the value of tangent x. Okay, letter B, he says, hence find the exact roots of this equation, where I think everything is exactly the same. Right? Yes, it's literally exactly the same. It just wants you to solve it now. So tangent x equals to negative root, okay, what is this? Okay, negative root 3 over 3. And so if you want to get x, you can just do tangent inverse. Just make sure your calculator is in radians mode, because it's from 0 to 2 pi. You're going to get negative 1 over 6 pi, which is not included. So go ahead and add pi to the answer to get the next one. 5 over 6 pi, fantastic. Okay, what about the third one? Could we get a third one? You're going to get 11 over 6 pi, which is still included, fantastic, and I think we can stop until here. And these are the two solutions, and these are the exact roots of this, equation. Okay, the parametric equations of the curve are given to you as x equals to root 2 plus 3, y equals to ln t, for t greater than 0. So obtain and simplify simplified expression for dy and dx in terms of t. Now firstly, we have to know that dy on dx equals to dy on dt divided by dx on dt. Now to get dy on dt, you'll just simply say, okay, that's supposed to be 1 over t because it's ln, and the derivative of ln is 1 over t. But then to get what's it called, the derivative of root 2 plus 3, so dx on dt, you're going to get 1/2 t to the power of negative half. Now if you divide the two together, you get dy on dx be equal to t to the power of -1 divided by 1/2 t to the power of negative half. Now that's going to equal to 2 times t to the power of -1 plus 1/2, which is the same as t to the power of negative half, and this is supposed to be the derivative. Now next we're going to have to find the exact coordinates of the point on the curve on which the gradient of the normal is equal to -2. Okay, if the gradient of the normal equals to -2, that means that the gradient of the curve is going to equal to 1/2. Okay, that's the opposite reciprocal. So now 1/2 is supposed to equal to the derivative, which we already know is 2t to the power of negative half, or 2 over the square root of t. And so radical to t equals to 4, and obviously if we square either side, we get t equals to 16. Now I didn't just ask for the value of t, he said to find the exact coordinates. So what we do is we're going to find the coordinates by substituting in the values of t into y and into x. So x is going to equal to root 16 plus 3, so x will equal to 7, and then y will equal to ln of what's it called, t, which is ln of 16. And so the point is going to be 7 ln of 16. So we've got question number 7 saying variables x and theta satisfy the differential equation, and he's given you the differential equation x over tangent theta times dx on d theta equals to x squared plus 3. So he says given that x equals to 1 when theta equals 0, so we've got a point. Okay, solve the differential equation obtaining an expression for x squared in terms of theta. Okay, so we're going to get x squared in terms of theta. So in order for us to do that, we're going to first just get all the x's on one side in order for us to integrate, and then get tangent theta on the opposite side. So here I've divided by x squared plus 3, and then I multiplied by tangent theta and multiplied by d theta. And so I just send all the x's to one side, all the thetas to one side in order for me to be able to integrate with the normal respects. Now here I can use the division law. I just need this to be the derivative, like the numerator to be the exact derivative of the denominator. And so all I need to do is just multiply by 2 up and down in order for me to avoid changing anything. And now I have 2x on top, which is exactly the derivative of x squared. Fantastic, we can just eliminate that and so the derivative is going to be ln of x squared plus 3. Now that's going to equal to the derivative, the integration of tangent theta, which we know that, in order for us to do that, we're going to first have to convert it to be sine theta over cosine theta, which we know cosine theta's derivative is negative sine theta, so you're going to have to multiply by -1 up and down, and so you're going to get negative ln cosine theta plus c. Okay, now let me just remove this. Okay, now I'm going to figure out what c equals to. So c is going to be, we're going to find it using this point, and so you're going to get 1/2 ln of x squared. Instead of x, just put 1 this time. 1 plus 3, it must equal to negative ln cosine of 0 plus c. Now cosine of 0 happens to be 1, and ln of 1 is equal to 0, so that cancels out. Okay, now you're going to get only 1/2 ln of 4 to be equal to c. So now the entire equation is in terms of ln, and so you're going to get x plus 3 equals to negative ln of cosine theta plus 1/2 ln of 4. Now in order for me to remove the ln, I'll first just make everything as like one, I can just combine them together using the multiplication law, then I can just cancel out the ln. So first let's remove any coefficients of ln. Okay, and that's just under the square root, which must equal to, and then again remove any coefficients of ln, plus ln of 4 to the power of half. So then you're going to get ln of radical x squared plus 3 to be equal to ln of 1 over cosine theta times 2. So it's 2 over cosine theta, also known as sec theta. Now we can go ahead and cancel out the ln, and so you get root of x squared plus 3 equals to 2 over cosine. And obviously you don't want that, you want to square because you want x squared in terms of theta, not the radical x squared. And so you get x squared plus 3 equals to 4 over cosine squared theta. You can send 3 to the opposite side, you get 4 over cosine squared theta minus 3. And that's an expression for x squared in terms of theta. Okay, now moving on. You've got question number 8. He says, by sketching suitable pair of graphs, show that the equation has only one root. Okay, so if it has only one root, that means it has only one intersection point. For us to sketch this, we could simply go, figure out a couple points that we would want to sketch. So for example, here, x and y, I can sketch the points, for the first graph, root x. Okay, 0, 0, we've got y equals to root x, we've got 1, 1, and we've got, 4, 2. Okay, for the second one, I can go, e to the power of x minus 3, let's say 0, and at x equals 0, it's going to be 1 minus 3, which is minus 2. And then what else could we do? We could do e minus 3 and e minus 1, and so that would be e minus 3. E to the power of 1 minus 3 is equal to negative 0.2817. It's going to round to 0.3, negative 0.3. One last point could be e squared minus 3, which is 4.3. So we've got 2 at 4.4, rounds to 4.4. So now getting y and the x-axis. Okay, that's weird, but anyway, we're gonna sketch the y and the x-axis. Here x and here's y, and then this is 0, and then here 1, 2, 3. Okay, so 1, 2, 3. Obviously use your ruler for scaling this, but I don't have my ruler right now, so minus 2. And then we also have to sketch minus 0.3 because we've included that point, and then x 1, 2, 3, 4. Okay, now sketching the first one, it's going to be starting at 0, 0, and then we're going to have a point at 1, 1, and then we're going to have a point at 4, 2. So that's right over here. Okay, and this curve is just going to keep extending like that, so let me just go ahead and sketch it. Okay, and obviously you can check here. Actually, no, the curve does not exist at y value is equal to negative. Y does not equal to negative. However, x equals to 0, y equals to 0. When x is a negative value, this doesn't exist. The function does not exist. So the function only starts from here until there. Okay, and then if we want to sketch the second one, y equals e to the power of x minus 3. So as we mentioned, we've got 0, and we've got the point minus 2. So at 0 at minus 2. And then at 1, we're at minus 3. So 0.3 right here. And then 4.4, we're at 0. At 2, we're at 4.42. And then we could just go 4. And this is 4.4. And so we can just go all the way until this one. And then since it's exponential, it's going to look something like this. And obviously you have to make it a little less squiggly. Okay, and yeah, perfect. We have only one intersection point, which shows obviously equals 1 root. Okay, so then he says show that by calculation this root lies between 1 and 2. So we're going to be using the we're going to show by calculation this root lies between 1 and 2. So we're going to have to get the function as just one function. And so we just send this to the other side, minus x plus e to the power of x minus 3. And then let's see what the value of f of x equals to when x equals to 1 and when x equals to 2. And so here we're going to get this equals to minus 1 plus e to the power of 1 minus 3. That's equal to negative 1.2817. And then f of x at, let's try here 2. Negative root 2 plus e to the power of 2 minus 3. So negative root 2 plus e to the power of 2, minus 3. That's equal to 2.9748. And you can see this is less than 0, but this is greater than 0. And so since the curve is going to go from negative to positive, that means that the function crosses the x-axis as f of x was negative at x equals to 1 and became positive at x equals to 2. And so that means obviously that the function crossed the x-axis. In general, obviously this is you can see here it's between 1 and 2 using our sketch. But in general, the function would have looked something like, I'm not sure how it looked, but like obviously between 1 and 2 the function was negative at 1, but then became positive at 2, and so we have a root between 1 and 2. Okay, now what's it called? Show that if a sequence of values given by the iterative formula, he says converges, then it converges to the root given in this equation. Okay, so in order for me to show that this iterative formula comes from this equation, and I'm going to just, change it such that it's certain in a way that, what's it called, looks like the previous one. So we're going to have ln, we could change the logarithmic function to be exponential, and so it's e to the power of x. First off, let's just start it as x equals to ln 3 plus root x, and that's equals to 3 plus root x, and then we could send e to the power of x minus 3 equals to root x, which is exactly the equation that he's given here, except like, okay, root x can be on the opposite side. And then we have, okay, use this iterative formula to calculate the root correct to 2 decimal places, giving the result of each iteration to 4 decimal places. Okay, so we're going to be using it starting at x0 equals to 1, which means that x1 equals to ln of 3 plus root, instead of what's it called x, we're going to put 1, and so ln of 4 is equal to 1.38, what's this, okay, 1.3863. Now x2 is going to equal to ln of 3 plus root and 1.3863. That must equal to, so let's go ahead and figure that out. 3 plus root of the answer is equal to 1.4297. x3 now directly put the answer is going to be 1.4341. x4 is going to equal to 1.4345. Now to 2 decimal places we can see that from here, like, we also achieved the answer, so x is equal to 1.43, and we could say what's it called, it's between, x3 and x4. x3 and x4, or x2 and x3 both give me the same result. So then what's it called, the diagram shows y equals to x times e to the power of negative 1 over 4x squared for x greater than or equal to 0. Its maximum point is at m, which means that dy on dx equals to 0 at m. Find the exact x coordinate of m. Well, that's fantastic, so we can just go ahead and say dy on dx equals to 0. And let's find dy on dx. We can use the multiplication law here. We can say it's the derivative of the first one times what's it called, second one. Oh, it's 1 over 4x squared. And then we're going to add this to the derivative of the second one, which is in this case, it's negative 1 over 4, but then negative 1 over 4 times 2, which is going to be negative 1/2 x times e to the power of negative 1 over 4x squared times the x. Okay, so here you're going to get 0 equals to, we can take e to the power of negative 1 over 4x squared common outside, and you get negative 1 over 2x squared. And so if we want to find the value of, now obviously e to the power of negative 1 over 4x squared does not equal to 0 ever, so there's no solution from here. However, there is a solution coming from this part, and so you get negative 1/2 x squared equals to negative 1. You get x squared equals to 2. You get x squared equals to, obviously, root 2. Now, you could do plus or minus, but you're going to have to pick the positive solution because x, as you can see, because x here is what's it called, at the positive axis. Okay, now what's it called, he wants the coordinates, not just the x value, so you're going to have to use the equation of the function to find the value of y. Y will equal to root 2 e to the power of negative 1 over 4 times root 2 x squared. Okay, so it's going to be root 2 times e to the power of negative 1 over 4 becomes just negative 1 over 4 times that equal to the whole thing squared, and that's equal to, so it will be root 2 times what's it called, e to the power of negative half, which is like saying root 2 over root of e. And so the solution is going to be root 2 times root 2 e to the power of negative half. Okay, now that's m. Now b says, using the x substitution x equals to root u, find by integration the exact area of the shaded region bounded by the curve, the x-axis, and the line x equals to 3. Okay, so basically the limits are going to be from 0 to 3, and if we want to use a substitution, so first, let's go ahead and get, the derivative of x, with respect to u, and that's going to be 1/2 u to the power of negative half. So dx will equal to 1/2 u to the power of negative half times du. Now the x here equals to 0 and x equals to 3 are the limits, but I want to change them to be in terms of u. And so 0 will equal to root u, u will equal to 0, 3 will equal to root u, u will equal to 9. And so here we're going to be integrating with respect to u. But first let me just copy down the equation of the function. Y equals to x times e to the power of negative 1 over 4x squared, right? X times, yes, exactly. Now if I want to integrate this, so I'm going to have to say y to the area is going to equal to the integral. Wait, let me just erase this. The area of the equals to the integral of the function taken with respect to x, and that's going obviously from 0 to 3. Now I'm going to use obviously the integration by substitution. So a area is going to equal to change the limits from 0 to 9, and instead of x we can put root u, exactly, e to the power of negative 1 over 4 times u instead of, x squared is going to be u instead of root u, because root u squared is u. Taken with respect to u, but obviously you're going to have to multiply by 1/2 u to the power of negative half, because dx equals to this stuff, okay? And so you just plug them in here, okay? Now when we multiply, u to the power of negative half by u to the power of positive half, this cancels out, and so you're just left with, if we take 1/2 outside, right, the integral of from 0 to 9 of e to the power of negative 1 over 4 u taken with respect to u. So here what we do is we just divide by the power, and so area is going to equal to 1/2 into the integral from 0 to 9. Obviously because we've integrated, so you're going to get from 0 to 9, e to the power of negative 1 over 4, you divide by the power in case you're integrating an exponential function. So just divide by negative 1 over 4, the derivative of the power, and then just, okay. Now in the case where we're integrating but we don't use limits, you're going to have to resubstitute back, x instead of u. So here then we're going to say, okay, instead of u, we're going to put x squared, and that would be the final answer. But because here we have limits, then just, plugging the limits using u is just what it's going to give you the exact same area as if you substitute using x. And so here we're going to just use the limits from 0 to 9, and then when you divide something by 0.25 or negative, you're just multiplying by negative 4, okay, 1 over 4, not u, okay, times 9. And that's the first one, minus 4 e to the power of negative 1 over 4 times 0 instead of u. And then you're going to get area to be equal to 1/2 from 0 to 9, negative 4 e to the power of negative, okay, so it's saying negative 4 e to the power of negative 9 over 4. And then minus becomes plus e to the power of 0, which is going to be 1, so it's plus 4. And so the overall area, if he wants the exact value, I believe, he wants to find the exact value of the area exactly, okay, times negative 2 e to the power of negative 9 over 4 plus 2, and that's going to be the area. Okay, next we have let f of x equal to the following, express f of x in partial fractions. To express f of x in partial fractions, we have to identify what we have here. So we have here case 3 of repeated, roots. Okay, so here what we do here is we're going to say 24x plus 13 over 1 minus 2x into 2 plus x squared has an identity of 1 minus 2x plus 2 plus x, and then 2 plus x and the whole thing is squared. And then you can just go ahead and do a, b, and c, and then you can say 24x plus 13 equals to a into 2 plus x squared, b into 2 plus x 1 minus 2x, c into 1 minus 2x. Okay, now now we're going to go ahead and use critical points. So instead 24x plus, let's figure out what the critical points here are. So we got, I think, x equals to minus 2, because that will eliminate b and a, allowing us to find c. We also have x equals to positive 1/2, because that will eliminate b and c, allowing us to find a. And then we're going to find the last term by comparing coefficients. And so let's first start by using 24 into negative 2 plus 13, which must equal to a, which is going to be multiplied by 0, that cancels, b, which is going to be multiplied by 0, that cancels, and then c into 1 minus 2 times minus 2, and that's going to wind up being 5c being equal to 24 times minus 2 plus 13, which is minus 35. If you divide that by 5, you get c equals to minus 7. And then if you get a, now here, in order for us to find you're going to use the second one. So what's it called? 24 times 1/2 x instead of x plus 13 equals to a into 2 plus 1/2 and the whole thing squared, and the rest cancels, and so you get 2 plus 0.5 squared, that's 25 over 4a, equals to 24 divided by 2 plus 13, and that's going to equal to 25. 25 divided by 25 over 4, that's equal to 4. A equals to 4. Now we've got A and we've got C, now we want to find the value of B. So by comparing coefficients, you will get A over, excuse me, sorry about this. By comparing coefficients, you can say what's it called here, for example, that b times x times minus 2x is going to be, the coefficient of x squared, and also the coefficient of x squared also comes from a times x squared, and so you get a plus, negative 2 times 1 times b, and then that's supposed to equal to 0 because there's no x squared in here, like the coefficient of x squared is equal to 0. And so a, which we found to be 4, minus 2b equals to 0, so b must equal to 2. And here we have the partial fractions. Now we can just simply say it's 4 over, and that's going to be 1 minus 2x. And then plus 2 over 2 plus x. And then minus 7 over 2 plus x and the whole thing squared. Okay, now next question says, hence obtain the expansion of f of x in ascending powers of x up to and including the term in x squared. So in order for us to expand this, first let me just copy down the partial fractions right here. And so we have 4 over 1 minus 2x plus 2 over 2 plus x and minus 7 over 2 plus x squared. Now if I want to expand this, then I will just take everything here with a negative power, and as long as we have a negative power, or a power that is, rational, such that it's like less than 1 and it's not an integer, so in that case I'm going to have to say that this expansion is going to have, it's going to be an infinite type of expansion, but we only want to find it until x squared. To expand this, we'll use the binomial expansion law in the formula sheet. So let's go ahead and do that. So it's going to be 4 into 1. Now first let me just remove the 4. Okay, first let me just simplify everything here. So we've got 4 into 1 minus 2x, the power of negative 1. Now in order for me to expand this, I'll say, okay, it's 1, and then I'm going to have to get the power times negative 2x, and then I'm going to have negative 1 times negative 2 divided by 2 factorial times 2x, and I'm going to stop at squared. And so the first one is going to be right here, and it's going to be 4 into 1 plus 2x, and then 4x squared. That's the first part. Now in the second one, you're going to have to remove 2 outside because you can't have, this, you have to have 1 plus something next to x, it's fine. Okay, so you have to remove any number that's not 1 if it's right here. So we're going to take 2 outside with the power of the part, okay? And then you're going to get 1 plus x over 2 to the power of negative 1. Now expanding this, you're going to get, now these 2 cancel out, and you're going to get 1 plus x over 2, 1 minus x over 2, minus 1, plus minus 1 minus 2 divided by 2 factorial times x over 2 and the whole thing squared, and you're going to stop until here, and you're going to get 1 minus x over 2 plus x squared over 4. For the last one, you're going to have to take negative 7. We're going to take out 2 outside to the power of negative 2 times 1 plus, okay, delete this. Alright, so we're going to get 1 plus 2 over, x over 2, and the whole thing to the power of negative 2. Expanding this, you will get negative 7 divided by 4, 1, and then here we could just get, negative 2 times 1 over 2, so it's going to be minus x, and then negative 2 times negative 3 divided by 2 factorial times 1 over 2 squared. And you're going to get 3 out of 4 x squared. Now expanding this, you get negative 7 out of 4 plus 7 out of 4x, and then it's negative 7 out of 4 times 3 out of 4 is negative 21 over 16. x squared. Now adding all these things together, you will get 4 into 1 plus 2 and 1 plus 2x. This can be written here as 4 plus 8x plus 16x squared. So now 4 plus 8x plus 16x squared, and then plus 1 minus x over 2 plus x squared out of 4, minus 7 out of 4 plus 7 out of 4x, and then minus 21 out of 16 x squared. Now get all the constants together, 4 plus 1, and then plus what else? Minus 7 out of 4. Yeah, 4 plus 1 minus 7 out of 4 is going to be 13 out of 4, and then 8 and negative half, and 7 out of 4 is going to be 37 out of 4x. And then lastly, you're going to get 16 plus 0.25, and then minus 21 out of 16, which is like saying 239 out of 16x squared. Now he says find the set values of x for which the expansion is valid. So we're going to get the set values of x for which either all of these fractions is going to be valid, and then we're going to get the intersection of all the sets of values. So for the first one, 1 minus 2x to the power of negative half, it's equal to the power of negative 1, you're going to get negative 2x, and you're going to make it equal to 1 from negative 1 until 1. And so x is going to be greater than negative 1 half and less than positive 1 half. That's one of the first sets of values. Then you're going to also get 1 plus x over 2 to the power of negative 1, or no matter the power really, you get x over 2 greater than negative 1 and less than 1. If you just expand this, you get negative 2 and 1 and positive 2, and if you get the intersection between them, from negative 2 to 2, this is huge, but then here from negative half to half, this is literally the intersection between them, and so this is the set values of x for which the expansion happens to be valid. Okay. Now next we've got 11, and the diagram shows OA, B, C, D, E, F, G. Alright, which is a cuboid with OA equals to 3 units, whereas OA happens to be 3i, and then OC is 2 units, so OC is 2k, and OD is 2 units, OD is 2j. He says unit vectors I, j, and k are parallel to OA, D, OD, and OC respectively, where m is the midpoint of EF. So if m is the midpoint of EF, then you have to know that it's equal to 1/2 of OE plus OF. But anyway, he says find the position vector of m. Well, that's literally what I was just talking about. Now let's first start by finding OE. Now OE is going to equal to 3i plus 2j, and then OF is going to equal to 2k right here, 2k plus 2j plus 3i. If you add them together and divide them by 2, did I say 2i or 2j? No, it's 2j plus 3i, and the whole thing times 1/2. So you get 6i plus 4j plus 2k, and the whole thing divided by 2 is going to be 3i plus 2j plus k, and that's equal to the position vector of m. He says the position vector of p is I plus j plus 2k. Okay, where's p? Well, p is not a point here, but in general he gave you, and know that p is supposed to be I and then j, and then you move up 2, and so it's going to be somewhere right here on the surface. That's p. Okay, the position vector is given to you. Anyway, he says find the angle PAM. So it's really just calculating the angle between the vectors AP and AM. Okay, because you just go from here to there and from here to there and just go AP and AM. Now to find AP, you're going to need to go, OP minus OA, that's the vector AP. To find the vector AM, you're going to need to go OM, second vector minus the first vector. Now OP is given to you, and it's 1, 1, and 2. And OA, you can find, I think, or it's given to you, it's 3i. And so it's just 3, 0, 0. And that's going to be minus 2, 1, and 2. Okay? But now for what's called OM, or default, it's 3, 2, and 1. Minus 3, 0, 0. And that's going to be 0, 2, and 1. So now if we want to find the angle between them, then we have to know that the rule says cosine theta equals to the dot product between AP and AM divided by the magnitude of AP times the magnitude of AM. Now the dot product here is going to be just, cosine theta equals 2. So let's figure out the dot product, okay? That's going to equal to, what's it called, 1 times, no, not 1, it's minus 2. So let me just write it down here as like, okay, it's supposed to be x times x plus y times y plus, what's it called, z times z, okay? Okay, now let's go ahead and do that. So it's going to be minus 2 times 0 plus 1 times 2 plus 2 times 1. And then divided by the modulus, which is just going to be the square root of what's it called 2 squared plus 1 squared plus 2 squared times the modulus of what's it called 0 squared plus 2 squared plus 1 squared. So cosine theta is going to equal to 4 divided by the square root of 2 squared plus 1 squared plus that's going to be 3 times square root of 5. And that's cosine theta. So cosine theta will equal to 4 root 5 over 15, which then makes basically allows me to find angle theta. So cosine inverse, and you get theta to be equal to 9 degrees, 4 over 3, 4 root 15, root 5 over 15, and that's going to be 53.39, which rounds to 53.4 degrees, and that's supposed to be the angle between AP and AM. And if we just look at the sketch, where is AP? It's right here. And where is AM? It's right here. And yes, the angle, as you can see, is acute, and it is 53.4 degrees. So let's find the exact length of the perpendicular from P to the line passing through O and M. Okay, so firstly, let's find the equation of the line passing through O and M. Let's figure that out. So R is going to equal to, well, we already know the position vector of M, and the first point, we can just write this down, and then the direction OM is supposed to be 3, 2, and 1. So 3, 2, and 1 times t. And we have what's it called to find the line. So this basically line is going from OM. So let's imagine this is OM. And then we have P right here. And then there's the foot of the perpendicular with this point. Let's call it R or whatever. Okay, so what's it called? We want to find this R in order for us to find, the point, what's it called, intersection between the two. Now, because we in order for us to find the length. So for us to find R, since it's lying on the line OM, then its position vector is going to have the equation of the line. And so if I find R, then I'm like OR is going to equal to 3t, 2t, and 1t. So when we figure out t, or how far along it is on the line OM, then we know where the point R is. But until then, we don't know it. So we want to find t in order for us to find R, which allows us to find the length. Okay, now one step of getting to that is knowing that between two perpendicular vectors, the dot product is going to equal to 0. Now here the vectors are going to be RP and OM. So let's find the vector RP in terms of t. So RP is going to equal to OP minus OR, second vector minus first vector. OP, we already know, is going to be 1, 1, and 2. 1, 1, and 2 minus 3t, 2t, and t. And that's going to be 1 minus 3t, 1 minus 2t, 2 minus t. Now the dot product between the two is going to equal to 0, which means 1 minus 3t times 3 plus 1 minus 2t times 2 plus 2 minus t times 1 equals to 0. Find the value of t from here. You get 3 minus 9t plus 2 minus 4t plus 2 minus t equals to 0. 3 and 2 and 2 is going to be 7. And then minus 9, minus t, minus 4, minus 14t equals to 0. Minus 14t equals to minus 7. T will equal to 1/2. Given that, we can find then RP, and because we already have it in terms of t. And then 1 minus 3 divided by 2, that's going to be negative 1/2. 1 minus 2 times 0.5 is going to be 0, and 2 minus 0.5 is 3 over 2. If we have the magnitude of if we have RP vector, we can find its magnitude just fine by taking the square root of x squared and z squared and y squared. So it's going to be negative 1/2 squared plus 0 squared plus 3 out of 2 squared, and that's going to equal to root 10 over 2, which, we can just keep it exact if we want, okay? And he said exact, so that we can just keep it exact, okay? So that's going to be the length. And that's it. Thank you guys for watching. Have a nice day and good luck.